Well, today I'm going back to work on the charging system on the Oliver, and before I take this alternator back out, which wasn't working last time I installed it, I am going to check the wiring because I might have a problem with the key switch, and if the key switch is not working correctly, then that would explain why I wasn't getting anything out of the alternator. If the key switch, if all my voltages check out correctly here, then I know I can definitely blame the alternator as the culprit. So the first thing I do is I check for 12 volts here at the large terminal, the output terminal, and I do have 12 volts there. Now I know that I'm going to have 12 volts there as long as it's hooked up to the battery, whether the key is on or off, because of the way it's wired. However, the next thing I want to do is I want to check, oops, come here. Next thing I want to do is I want to check and see if there is 12 volts coming in on this red wire, which is the sensing wire, and that should have 12 volts on it. That should have 12 volts on it when the key is in the on position. Okay, so I just checked and I've got 12 volts on that connector on the red wire, and the white wire doesn't have 12 volts on it unless I put 12 volts on it by touching that connection under the dash there, because I never wired this in completely. That white wire actually is eventually going to go to the idiot light, and hopefully we'll be able to wire this up so that the alternator excites by itself. I don't want to get into this whole thing where I'm messing with a system using an external voltage regulator and that, although I know sorry, I forget the name right now, but I'll put it up on the screen. He had posted that video showing how he's got that little Bobcat charging system working. But I'm still convinced that I can get this to work as if it's almost like a one-wire alternator and charges. So let's work on that. All right. So I'm going to do a couple of things. I'm going to start the engine so that I can try the alternator one more time before I take it out. And also, so I can raise the loader and get the loader arms out of my way. So let's see. It's nice and warm today. It's about 65 degrees. So let's see how cold start is. Battery's low. I just put the battery charger on it, so I didn't expect it to be charged that quick. Let's see if I can use the starter charger feature to give it some boost. Let's try that. Almost. Do that one more time and it should work. Alright, I'm going to disconnect the charger because I don't want the 12 volt coming in from the charger to be confused with any other voltage measurements I make. That's plenty of room now. The loader fully extended, I got plenty of room to work. Alright, so let's get under the dash. Well, it's funny, the way I have this wired, if I touch this white wire to the one side of the idiot light, that light should be lit if it's not charging. And then once the engine starts, that light should go out. The funny thing is, the light doesn't light. The light's not lighting because I have 12 volts coming on here. So there's 12 volts on both sides of the light, so of course there's no voltage drop across the light. No current will flow. The light doesn't light. Question is, why is it 12 volts here? There shouldn't be 12 volts here unless it's charging, but it's not charging. At least not according to the ammeter. Let's check out that output on the other side. Now all I have to do is look at the voltage on the meter here and rev the engine. Now even with regulation, the regulator should keep that voltage from changing dramatically, but you should definitely see some change. There's no change at all. And if we kill the engine, that's probably going to stay right at 11.85. There you have it, 11.85. So with the motor off, it's still doing the same thing. Now, with the motor off, if I hook that wire up to the light should light. So, and it doesn't. So what that tells me is, I can check, but I bet you there's still 12 volts at this point. Alright, 12 volts, and I'm right on the white wire at the connector. So what that tells me is, more than likely what's wrong with this is the regulator IC or module in here is bad. See, the white wire is the connection closest to the top here. Oh, it looks stuck. There we go. I mean, unless I get a short in the wiring. All my wiring is new, so that's not likely. Yeah, that's interesting. Now I'm not getting anything there. Not getting any reading now. But I bet you the reason why I'm not getting a reading now is because 12 volts isn't running in from this wire to the alternator. So that tells me it's almost like there's a short between here and here. Just for the heck of it. Let's check the continuity between those 2 points. Hold on a second. Well, there's some kind of a reading on the meter, but I don't know. But I am satisfied that it is still internal to the alternator. Okay, got the alternator all the way off except for this one connection because the nut that I've got on there is a 10 millimeter. So, go figure. Obviously that's a newer alternator. It's got metric. So, now, in case you're wondering, no, I hadn't disconnected the battery. I really should disconnect the battery, but I'm just going to put this rubber cap over it. Try and make sure the cable doesn't hit anything. Now, as I've mentioned before, I can get an alternator for 30 bucks at the auto parts store that'll replace this one. But, believe it or not, I'm going to take it apart again. I mean, what the heck? It's getting so easy to take this apart after doing it so many times. Okay, as you've seen me do several times before, if you've been watching all the videos, you take the 4 screws out, and then you separate this, and you want to separate it on this side of this armature so that the armature windings stay with the back when you pull it off. And that came apart like a piece of cake because I've had it apart just recently. So now you can look at this. I want to get my ohm meter and take a measurement here. Now, an ohm meter isn't the proper tool for checking windings, but I'm not an alternator repair shop, so I'm just going to do it just because I want to see. It's a quick little go or no-go test, so to speak. I mean, if it passes with the ohmmeter, that doesn't necessarily mean it's good, but it's a good indication that it may very well be good. If it fails, well, then there's no need to go any further. So what I'm looking for is I'm looking for continuity between here and here, and I don't want 0 ohms, which would be a short. So I am having trouble getting it to stabilize. Get fingers on here and hold it. I'm getting a resistance reading pretty low. I'm actually kind of surprised it's that low. I'm curious what the other one reads. This is what's left of the alternator number 1, the one that I completely destroyed. It's actually the same. Now, could mean that they're both bad, but I actually think that they're both good. The reason why I think they're both good is because I think the problem with this alternator actually lies somewhere else with one of these internal components here. You've got this rectifier assembly, you've got this diode trio, you've got the brush assembly, and then the regulator itself. And this alternator also has this device right here, which is a resistor, and this device right here, which is a capacitor. And I believe that the purpose of this capacitor and this resistor have nothing to do with charging, but have to do with filtering noise from the alternator, electrical noise, which in an automobile can be bad news because, well, in the old days it would really mess up your AM radio reception. And then in modern automobiles, the more sensitive electronics would not like to see that kind of noise and garbage getting through in the DC system.